this is a beautiful day again. I'm going to find the solution to this question. So my question here is to find the area of a region D given by these different lines and curves. So the first thing to do they're asking us is to find the make a sketch. So make a sketch. So I'm gonna start with this one. I'm gonna graph this equation of y is greater than or equal to x squared minus 4. So I know that because I have this x squared, my graph is gonna look like a U-shaped up, so it's gonna be a quadratic equation. Well, my origin is gonna be a -4 because if I substitute 0 for x here, my y-intercept is gonna be -4. So I can come here and put my origin here, and then since I'm drawing a quadratic, it's gonna look something like this. Okay, I'm gonna just use the tool that I have in order to, yep, there you go. Now, the second thing to do, because we're given an inequality, we want to find which region we're going to be shading. When I have a graph, when we say y is greater than or equal to x, or x in a certain equation, x squared, x minus 2, or whatever, we're going to shade the area above the curve. So basically, this area inside is the one that I'm going to be shading, right? Above the line. But don't take my word for it. I want to prove that actually this inequality will work if I shade this given area inside. So what I'm going to do, then I'm going to take a point that lies inside of this curve. So I'm going to take the point 0, 0 because that's the point I like. I'm going to take this point 0, 0 here and come use it here. So when y is 0, we want to check if 0 is greater than, if I put 0 here, minus 4, if this works. So as you can see, 0 to the power of 2 is just 0, minus 4 will be -4. So that means that 0 is indeed greater than -4. So we are right to shade this area. Second, we want to graph this one where y is now less than or equal to x plus 2. I'm going to come here and look, this reminds me of an equation of a line where it's going to look straight because my slope here is of 1. So this looks like mx plus b, right? Where we know that where we know that b has to be the slope, and here, since I don't have anything, that means that my slope is 1, right? So my line is going to look something like a straight line. Where is it going to go from? It's going to go from an origin of 2, because if I put 0 for x, so when x is 0, y is going to be 2. So I'm gonna draw a line that goes like this. Hopefully it hits the 2. Yeah, close enough. I can modify that so that it touches the 2. This is not drawn to scale. I just want to show you what's going on here. And I'm gonna come and see this and extend this one again, and put it down here so that you see what is going to happen. And then, right, I want to check now again which area I'm going to be shading. Since we know that when we use y greater than or equal to a certain x value, we're going to shade the area inside or above the line. When we have the opposite is true, when we have y is less than or equal to a certain x value, now instead of shading the area above, we're going to shade the area below. I'm going to first shade and prove you that this is indeed the area that we are going to be shading. Because once again, I can take the point here, 0, 0, and check if it will give me this value. So if I take 0 for y, and I take 0 for x, I end up with 0 is less than or equal to 2, which indeed works. That means that this area is the area that I need to be shading. Perfect. Now let's move on to our next graph. What do we have here? We have y is less than or equal to -3x plus 6. Amazing. This is the same as this one here, but instead of having a slope of 1, we have a slope of -3, which means that our slope, we have a negative slope. That means that instead of having a straight line going up, we have a line going down. So what is going to the point of origin? It's going to be when x is equal to 0. Here I'm going to have 6. So when I do -3 times 0 plus 6 is -3 times 0, give me 0, and then I end up with 6 left behind, which means that I'm going to start from here where my y value is 6, my x is 0, and I'm going to draw a line that goes all the way down from that point. Please work. Yep, there you go. I can modify this and organize it better. This is not going to look exactly like it's supposed to be, but as I said, it's not drawn to scale. It is not drawn to scale, right? So in this case, now we end up having this again, where we need to shade the area. As we've seen from the example here before, this one here, we know that we need to be shading the area underneath the graph. So that means that I'm going to automatically, just for the sake of time, shade this area here. Amazing. You're actually going to go even below here and below here and blah, blah, blah. So remember, we were asked to find the area of the region D. So we need to find what this is. So we have our area which is surrounded by those three lines. Those three lines, when they meet, those three curves, when they meet, they form this shape that we want to figure out what the area is of. Now, in order to do that, we need to use integration. But before we use integration, we need to find which point we're going to be using in order to find our integration. So we need to find our bounds. In order to find our bounds now, we need to find where are those lines intersecting, where are those lines ending, in order for us to make sure that when one ends, the other one is starting. So we're going to take this point here, where those two lines are meeting. The other point is actually here above, where those lines are meeting, and another one is right here, where those two lines are meeting. Sure. So now, what are those two? What are the lines that are meeting here? We have this line of x squared. Sorry, my ink is actually very big now. So I have x squared minus 4, and we have this straight line going up, which was x plus 2. Amazing. So my x plus 2 was the other line that was meeting here. When two lines are meeting, that means that they have the same value of x, and the same value of y. That means that if I make these two, x squared minus 4 equal to x plus 2, I'm going to have to find what value of x will make sure that those two lines will meet at exactly the same point. So I'm going to solve for x in this case. Let's go and do that. So x squared minus 4 is equal to x plus 2. And I can bring the 4 here because I don't like working with negatives. So I end up with x squared is equal to x plus 6. I think we're good here. And I can bring this back here. And this will make my equation be x squared minus x minus 6 is equal to 0. Right? So now I want to figure out what x value is going to be here. So I'm going to use factors. So for this factor, I can use, I'm going to be using x negative 2, x negative 3, and x positive 2. These are my factors. And you want to check how I did it? Okay. I can even, I use the method I was taught to me at home, where I take this, the coefficient of the last one, of the last digit here, and the coefficient of here. So here we have 1. So 1 times negative 6 give me negative 6. So I want to find what two numbers, if I multiply them, will give me negative 6, but if I add them, they will give me negative 1. I end up with negative 3 and 2, because if I do negative 3 plus 2, that will give me negative 1. If I do negative 3 times 2, that will give me negative 6. So I'm set to go. And I can even check it here. If I do x times x squared, x times 2, that's mean 2x, and then this one, that will give me minus 3x, and this will give me negative 6. So that works, because if I add them, those two, I end up with negative x. Amazing. So now, remember that this was all set to be equal to 0, solving for x, that end up with x is equal to 3 and x is equal to negative 2. I'm going to keep them here. And I can come up here to find a solution for those two lines. Those two lines were x plus 2, I think, right? Yep, x plus 2, and then this one, negative 3x plus 6. I'm going to equate them to one another. Actually gonna solve it above because I will not have space below. I'm gonna do it here. So I end up with, if I want to, I can bring this one here. So I can bring 2 on the other side. So I end up with x is equal to negative 3x minus 4. I bring this one here, so the sign changes, so it becomes x plus 3x. That gives me 4x is equal to negative 4. Is equal to 4, sorry. Ooh, my bad, sorry. Actually, it's equal to 4, sorry, because I confused the sign, sorry. Is equal to 4. Almost made a mistake. And I'm going to solve, since I'm solving for x, I can divide both sides by 4. I end up with x is equal to 1. That was an easy one, so I'm not complaining, loving it. Right? Now, I can come here where my lines were negative 3x plus 6, and then that meets the line x squared. Is it minus 4? I keep on forgetting. Yes. X squared minus 4. I'm going to be solving for x once again because I don't like to work with negatives. I'm going to come here and bring my 4 on the other side. So I end up with negative 3x plus 10 is equal to x squared. Then I end up with bringing all these two things on the other side and make it equal to 0. So I end up with x squared plus 3x minus 10. Once again, I want to find a number that will give me, so if I take negative 10 times 1, because the coefficient of x squared is 1, that will give me, sorry, I'm just going to do this. There you go. That will give me, so I do x squared, that will give me negative 10. What answer, if I multiply them, will give me negative 10, but if I add them together, they will give me 3. So I can do negative 5 and 2, because if I do 2 times negative 5, okay, oh, sorry, actually it's 5 and negative 2, my apologies. So if I do 5 times negative 2, that will give me negative 10, but if I do 5 plus 2, so negative 2 plus 5, that would give me 3. Amazing. So I end up with my factors of x plus 5 and then x minus 2. Solving for both, so I end up with x being negative 5 and 2. So those two lines meet when x is equal to negative 5 and then x is also equal to 2. Amazing. This now helps us a lot because we know different places we are going to start. So let's come down here again. We know when we look at this graph, we can see that this point here is actually on the negative side of the x-axis. So this point 3, actually, we don't need to use it. We're going to start using 2. And here at the top, the one we just found, 1, that's perfectly fine. And the one we recently found was x is equal to negative 5 here, and then 2. If I look at this graph once again, this portion of the graph is actually on the right side of the x coordinates, on the x-axis, sorry, which means that it's on the positive. So this negative 5 is not what we're looking for. We're going to be using 2. Now, next step is to set up set up our equation to find the area under the curve. I'm going to come and start with this point here. How do I do that? In the way I was taught and the way I usually do it is I want to take the top line, the top curve, minus the bottom curve. And I would do it all over the place. So if you look at from here, from this point, I'm going to actually change colors so that it makes more sense. From this point here to this point here, the line on top is actually the line of x plus 2, right? That line is above this line below here, which is our x squared minus 4. And then when I go from here, the top one where x is 1, all the way to when x is 2, this new line, the negative 3x plus 6, is the one that is above. And once again, the line of x squared minus 4 is still below. This means that I'm going to find the area going from this point to this point, and then from this point all the way to this point here. So I'm going to go ahead and set up my equation. I want to find the integral going from -2 to 1 of what? The line above minus the line below. So the line above is x plus 2, and the line below is x squared minus 4. And I want to find this area. I want to add it with the other extent, the other side, which is basically this one. So I just found with this, I found the area of with the first set of equation that I just did there. I'm finding this area. I'm going to call it A. And with the other parts, I'm going to find area B. So when I add area A and area B, I will get this whole area that was always being asked to find, which is D. Perfect. So I'm going to set up again the other part of the equation, other part of the integral, where I have now, I'm adding the integral from 1 to 2 of -3x plus 6, because that's the line that is above. Once again, minus the line that is below, which is x squared minus 4. Now it's time to start working. So I distribute the negative inside, I distribute the negative inside. So I end up with integral of from 1 to 2 of x plus 2 minus x squared plus 6 plus the integral from 1 to 2. Oh, so this is -2. So from -2 to 1, sorry. Here is from 1 to 2 of -3x plus 6 minus x squared plus 4. So I continue, simplify this. So 2 and 4, 2 and negative. Sure, what's going on today? I can't seem to be doing math properly today. It's plus 4. Sorry, I skipped ahead. So if I add 2 and 4, I end up with 6. So my new integral becomes from -2 to 1 of x plus, no, x minus x squared plus 6. Yep. Plus on the other side from 1 to 2 of -3x. If I add 6 and 4, that gives me 10. So minus x squared plus 10. So we're all set. The only thing that is left for us to do now is to find the integral, to find the antiderivatives, and then use our bounds to find the answer. So I can come down here, find the antiderivative of this one, knowing that the bound is going to be from -2 to 1. So that is going to be antiderivative of x is x squared over 2. Antiderivative of x squared is x cubed divided by 3. And then antiderivative of the constant is basically just 6x. I'm just going to add x. And our bound is from -2 to 1. Plus, same thing here, I'm taking the antiderivative. So I'm going to end up with, sorry, I'm just going to do something like this. -3x squared over 2 minus x cubed over 3 plus 10x, going from 1 to 2. Now, here what I'm going to do is that I'm going to put the upper bound substituted for every x value, right? After I substitute for every x value, I would do the same thing with the lower bound, and then subtract the lower bound from the upper bound. So let's do that right now. It's time to use my calculator because I am not a machine. My upper bound is 1. So I have 1 squared over 2 minus 1 cubed over 3 plus 6 times 1. This whole thing minus, I'm going to shift this a little bit on the side so I have space there. Okay, let's continue. Minus, it's -2, right? Okay, -2 squared over 2 minus -2 cubed over 3. Please be careful with those numbers because they can actually be confusing. So here, always double checking, is everything okay? Sure. And on the other side, I have -3, my upper bound is 2 squared over 2 minus, okay, my x is once again 2, just as I said, it can be confusing, cube over 3 plus 10 to the power of 10 times 2. This, now the parentheses here, minus -3, the upper lower bound is 1 squared over 2 minus minus 1 cubed over 3. This is actually long. Good. Now, plug this one in your calculator. So I'm going to end up with 1 over 2 minus 1 cubed plus 6. What does that give me? 1 over 2 minus 1/3 plus 6. This gives me 37 over 6. And then this one, so I end up with -2 squared. The reason why I'm using my calculator is because usually with these questions, you might make mistakes without even knowing them. I had to try it many times before I finally figure out how to make this one work. So please do not judge me for this one. And if you want to judge, go ahead. It's math. I love it anyways. So divided by 3 here, and plus 6 times -2. So this will give me, this gives me here -22 over 3. So I can of course subtract them from one another. So I end up with 37. So when I'm subtract, that means that the sign is going to change, it's going to become plus. So I can just do 37 over 6 plus 32 over 3. So that gives me 27 over 2. Perfect. And I can do the same thing on this side. But now I have -3 times, okay, -3 times 2 squared divided by 2. Minus 2 cubed to the power of 3 basically, divided by 3 plus 10 times 2. Okay. This gives me 34 over 3, and I can reproduce the same thing now, just changing from 2 to 1 basically. I'm gonna do it here. What am I getting? I'm getting 49 over 6. So 34 over 3 minus 49 over 6. That gives me, so this minus this gives me 19 over 6. Whew, that was a long one. And then I'm adding here those two sides of the equation. So I'm adding to this 27 over 2 plus 19 over 6. So the answer that I just found plus that. Sorry. So I'm going to do 27 over 2 plus 19 over 6. That gives me, according to my calculator, it gives me 50 over 3, which is roughly 16.6666 and so on. So this should be the answer if our math is right. And I believe it is. So thank you again for watching. Don't remember, if there's anything that I did wrong, just let me know so I can correct it immediately before inducing anybody else in error. Thank you so much. Have a nice day.